These are the frequently asked questions for pre-calculus for section P2 from the prerequisites. And the first one is number 10. And it says, rewrite the expression without using the absolute value symbol. So what we have to remember is that the absolute value symbols are there because everything that comes out needs to be positive. So if we try to rewrite number 10 by just taking off the absolute value bars, square root of 5 is 2.2360679777 using the graphing calculator, and 5 halves is 2.5. If we do that, the answer will come out negative. That's not what they asked. They want us to rewrite the expression so that it is exactly the same value, but without the absolute value piece in there. So what we need is to get rid of the negative. And how we're going to do that is by reversing it. Because if we take 2.5 minus 2.2360679777, we will get the same approximation, but it won't be negative. And that's what they wanted. So there it is. So we just reverse that order. Next one on your list was 19. And 19 says, find the area and perimeter of the figure determined by the points. And I didn't give you graph paper for this, so I'm going to use this as if I didn't have graph paper, just like you did. And what we needed to do was figure out the distance from negative 5, 3 to 0, negative 1, from 0, negative 1 to 4, 4, and from negative 5, 3 to 4, 4, all three sides. So distance, again, is the square root of the change of the x's squared plus the change of the y's squared. Negative 5 minus 0 will be negative 5 squared. 3 minus a negative 1 would be 4 squared. So that will give us the square root of 25 plus 16, which is the square root of 41. I go to the next one, distance equals the square root of, and I'll go in the other direction this time. 4 minus 0 is 4 squared. 4 minus a negative 1, 5 squared. And that will again give us the square root of 41. So this triangle is isosceles. And then we go to the last step, and this side, 4 minus a negative 5 will give you 9 squared, and 4 minus 3 squared will be 1 squared. So that's the square root of 81 plus 1, which is the square root of 82. Now, what do I need from there? Well, they wanted the perimeter. And the perimeter is what you get when you add all of those together. Now, we try simplifying the square root of 82, but nothing's going to go into that. All we can do with this is say, well, here's what we know. We know that the square root of 41 plus the square root of 41 is 2 square roots of 41 plus the square root of 82. And then I just slap a label on there, units. I mean, that's perimeter. Now, area. I started thinking, well, area equals 1/2 base times height. And there was something very suspicious about the fact that both of those were the square root of 41. And this was the square root of 82. So I would investigate that and say, you know what? This works in the Pythagorean theorem. A squared plus b squared equals c squared. The square root of 41 squared plus the square root of 41 squared does equal the square root of 82 squared. That means this is a right triangle. Well, that's fabulous news, because if it's a right triangle, I'll be able to see which one is the base and which one is the height. Because of that attachment by the right angle. So I did make a quick sketch of it. You could just slap something together on your paper. But what you need to figure out is where's the base and where's the height. That's the key. And you realize that from negative 5, 3 to 0, negative 1, is the base or the height, and from 0, negative 1 to 4, 4 is another height. So base or height actually. So these two are your base and your height. So area equals 1/2 base times height. Well, the square root of 41 times the square root of 41 is 41. So it'll be 41/2. And because this is supposed to be, I guess, kind of a word problem in that we actually want to figure out what the area is, we probably would go 20.5 with this. 20.5 would not be wrong. Units squared. Because again, when we're trying to find something that you would talk about with people in the real world, I mean, you do talk about square feet, square yards, whatever it is when you're planning flooring. You probably want to do that. All right, next on your list was problem number 20. So I'm going to erase this and work on number 20. All right, so for number 20, again, this is a find the area and perimeter of the figure determined. Now I look at 20 and I'm suspicious right away. You should look at that and say, gosh, that's a lot of repetition. That's possibly going to be a rectangle or a square. It's something that I'm supposed to notice here. And then again, you could just make a really quick sketch and you're going to see, oh, yeah, now I see it. That is a square. So if it's a square, all I have to do is count to get any of the side lengths and use that. So the side length for each one of these is going to be 4. That makes the perimeter 16 units, and the area would be 4 times 4 because that's going to be area equals side squared, so that will be 16 square units. So there's number 20. And again, what you notice about the numbers right away is there's just too much repetition here for this to be coincidence. And whether or not you have graph paper or you just make a quick sketch, that visual will usually help you through it. Then 36. 36 is asking us to use the graph of the investment value of $10,000, an investment made in 1978 in Fundamental Investors of the American Funds. The value as of January is shown for a few recent years in the graph below, and then they give us the source of this data. But what we care about for 36 is we are supposed to estimate the percentage increase in the value of the $10,000 investment. So for A, they want to know what is that percent increase in the value from January of 1996 to January of 1997. Now this is definitely bigger and a little bit easier to see once I have it on the smart board here. And what we want to do is think, okay, if we need the percentage change, what we really need is to figure out how much has it changed and then divide it by the original. So in this case, I would say in 97, it's about 180 from the graph. And then it looks like maybe a little bit above 140, so maybe like 142. And then remember that it started off at that 142. And then you just punch it into the calculator and get it as a decimal so you could change it into a percentage. So we do 180 minus 142, and that comes out to 38. And we divide that by 142, and that is 0.2676. And that's approximately a 27% increase. I'm just going to use an upwards arrow for increase there. So about a 27% increase. Like I said, it's much easier to see these on the smart board. When I read this off in class, just looking at my book, it was so tiny it was hard to figure out where those individual dots were really placed. All right, now I'll erase this one and go after B. In B, we want January of 2000, which is right here, and January of 2001. And I notice this is a decrease, so part of my answer will be that this was a decrease. But I need to know how much the decrease was. So, and double zero here, we have, boy, that's looks like just about 280 there, but maybe not quite that. 275, 280, somewhere along those lines. And then the other dot appears to be maybe at about 200 and, well, it's above the 240 line. We'll go with 245. And we divide that again by the original. Now the one that came first was the 275, so that's what we have to use. So that means if we have 275 minus 245, that's 30 divided by 275, and that comes out to about 11%, but this was a decrease. Now, if you're saying to yourself, well, I put the 245 up here and the 275 in the back and it came up negative, yes, you can do it either way, and that's because the negative is telling us that it was a decrease, and you can do it that way as well. So second one, about 11% decrease. Then C, January 1995. Well, that looks to be at 120. And what is it at the end? Well, at the end, it looks like, well, I'm going to go with maybe 315. And again, it doesn't matter if it's positive or negative, so I'll do 315 minus 120. And then we have to have that over the original, which was 120. And so let's punch this into Mr. Calculator here, Mr. or Mrs. Calculator, or maybe it's Ms. Calculator. 315 minus 120, and we're going to divide that by 120. 1.625. So we need to change that into a decimal, from a decimal I mean, to a percentages. So that's about 163% for that increase. And again, you know, depending on how close your dots were to where they actually were, that's where you're going to match what we have for the graph using your points. All right, number 67 says, we are supposed to let AB be some point in the first quadrant. Best thing to do is just pick a spot where there's nothing unique about it. It's just a spot somewhere, a point somewhere in the first quadrant. And it says, find the coordinates of the point Q in the fourth quadrant so that PQ, because this is point P, would be perpendicular to the x-axis. Okay, so I'm just going to go straight down because here's my x-axis and I want to be perpendicular to it. And I think, okay, something easy to do, I'm just going to go the exact same distance down. So this would still have A for the first coordinate, the x-coordinate, but now it would be a negative B in the other direction. And that's what they wanted us to think about, you know, what's going to happen to the signs as we change those. And that was it for your questions for section P2.